Lactose intolerance is the most common food intolerance in the world. Rare in infants because they can easily digest lactose in breast milk, its incidence skyrockets with age. And your genetic ethnic background is the key predictor of your risk of developing it. In this podcast, I'll look at the causes, signs, and symptoms of lactose intolerance, and then go on to explain how it is diagnosed and, importantly, how it can be managed. And the good news is that rarely does that mean the exclusion of dairy products. Welcome to the Thinking Nutrition Podcast. My name is Tim Crow, and I'm a career researcher, educator, and science communicator with most of this spent in the field of nutrition. How do you make sense of so much conflicting information in the field of nutrition? Well, I don't profess to have all the answers in an area that is continually changing as research changes. You can count on what is covered in this podcast to be based on the whole field of nutrition science, not just selective areas that support a particular way of thinking. And this podcast will always be free from any commercial product tie-ins, endorsements, or advertisements. Just credible nutrition science presented in plain and simple language, and then translating this into what it means for your health. So, on with today's show. Lactose intolerance is a digestive disorder caused by the inability to digest lactose, which is the main carbohydrate in dairy products. Lactose intolerance is a condition where symptoms are directly attributable to the malabsorption of lactose. This can be caused by either a reduced or absence of activity of the enzyme lactase. Lactase, which is found on the surface of the intestinal lining, is needed to digest the disaccharide lactose sugar into its single sugar units of glucose and galactose. And to note, lactose intolerance is different from a dairy allergy. In a dairy allergy, the body's immune system reacts to milk proteins, not milk sugar. A milk allergy can result in many symptoms, some of them very severe, including anaphylaxis. The degree of symptoms someone experiences with lactose intolerance depends on several factors. These include the amounts of the lactase enzyme present in the intestinal wall, the intestinal microbiome flora, which is unique to each person, the amount of lactose consumed, and the motility of the gastrointestinal tract. How common is lactose intolerance? Worldwide, it is put at around 60%, but the distribution is very uneven. In countries like Australia and the USA, it is closer to 50%, while in Asia, it is 70%. And in Africa, it is close to 100%. But even at a country level, there are clear ethnic differences, where prevalence rates drop down to about 15% in people from a Caucasian background. And in Scandinavian countries, it is barely registered, with a prevalence rate of just 2%. Why such differences? Several theories have been put forward to explain it. The main one, which seems the most plausible, is based on the observation that dairy products played an important role in the diet in Northern Europe over the centuries. This provided a natural selection of people capable of digesting lactose. So, with later time migration rates, it still reflects this pattern. And all those prevalence numbers I quoted, though, of course, don't apply to infants. From the 8th week of gestation, the activity of lactase can be detected on the mucosal surface of the intestines, and this activity progressively increases until it reaches its maximum peak at the time of birth. So the newborn is all set to digest lactose in breast milk. It is the decline of lactase activity post-weaning and into adulthood that is the issue that explains most cases of lactose intolerance. And this is called primary lactose intolerance. In primary lactose intolerance, lactase production falls off sharply by adulthood, making milk products difficult to digest. If you can't digest lactose, then it has only one place to go, and that's into your large intestine, where it makes a great fuel source for your gut bacteria. Of course, all that fermenting action means the production of metabolic byproducts and gases, and all compounded by excess water being drawn into the GI tract. Symptoms of lactose intolerance generally appear when the percentage of lactase enzyme activity is less than 50%. And those symptoms: abdominal pain, bloating, flatulence, diarrhea, rumbling and gurgling noises, nausea and vomiting. On average, symptom onset occurs about 1 hour after consuming foods containing lactose. But not everybody with lactose intolerance will develop symptoms of the same intensity. This is due to varying amounts of gas produced by each person, and here their bacterial flora will make a big impact on this, but it also depends on their sensitivity to intestinal distension. Diarrhea can be explained by the production of fermentation byproducts called short-chain fatty acids, which acidify the colon and draw in water, creating an osmotic effect and diarrhea. Symptoms of lactose intolerance, though, can occur outside of the gut, with memory issues, headache, musculoskeletal pains, heart rhythm disorders, depression, anxiety, ulcers, disturbances of the menstrual cycle, and even eczema linked to it. These disorders could be caused by the excessive production of chemical substances such as acetone, acetaldehyde, ethanol, peptides, and others which are formed in the course of maldigestion and malabsorption of lactose. Just a quick side journey here. I've heard it said far too many times that lactose intolerance is a sign that it is not natural for people to drink milk, because humans are the only mammals that continue to consume milk after weaning. This is, well, pretty silly logic. It's also wrong. Humans are the only species that do thousands of things differently to animals. No animals I know of take pictures of their food for others to view on social media. So that appeal to nature fallacy is a pretty weak argument. Humans drink milk because they can. They've domesticated animals and use this to their advantage as a rich source of nutrition. And the claim that we're the only species that drink the milk of other species is just plain wrong. Firstly, in the wild, an animal that preys upon another animal that is lactating will, without a second thought, consume the milk as part of its meal. And then there is the fascinating observation of feral cats who have been seen in the wild drinking, or should that be stealing, elephant seal's milk from the teats of nursing females. Why? Because they can get away with it. Okay, back into the theme of today's podcast. So how is lactose intolerance diagnosed? One way, at least in determining if someone has a genetic predisposition, is based upon a genetic test to look at unique DNA changes, called polymorphisms, for the gene coding the lactase enzyme. Such a test is useful to distinguish between primary and secondary lactose intolerance. Primary lactose intolerance occurs as the activity of lactase declines as people age. Secondary lactose intolerance is due to injury to the small intestine as a result of infection, celiac disease, inflammatory bowel disease, or other diseases. Then there is the hydrogen breath test. This is the most frequently used method to diagnose lactose intolerance. The test exploits the phenomenon where the fermentation of lactose by the microbial flora produces gases, including hydrogen. The test involves the measurement of exhaled hydrogen after taking on a load of about 50 grams of lactose. Other methods for diagnosing lactose intolerance include direct measurement of lactase activity done after a biopsy of the intestinal mucosa. This, though, is a pretty invasive test that needs to be done by endoscopy. There is also a blood test that looks at the change in glucose levels over 2 hours after taking on a 50-gram load of lactose when fasting. If the lactose isn't being digested, then little to no glucose will be liberated, so blood glucose levels won't change very much. It's an easy test to do, but has low sensitivity and specificity for diagnosing lactose intolerance. So how best to manage lactose intolerance? Excluding all lactose seems like the most obvious path, but not everybody needs to go to this level for what is, after all, an important source of calcium, proteins, and minerals, if somebody otherwise has no need or desire to cut back on dairy foods. Many people with lactose intolerance can tolerate up to 15 grams of lactose per day without any obvious symptoms. That's equivalent to a glass of milk. And it may be better to consider the full fat variety, as the extra fat can slow the journey of the milk through the intestines to allow lactase more time to do its job. But if you're looking at yogurt, then 200 ml will contain about 10 grams of lactose, though this can decline over time as the bacteria slowly use up the lactose. The amount of lactose in a serve of most cheeses is well under 2 grams, and the harder and matured cheeses, such as cheddar, Swiss, and brie, contain tiny amounts, so there is no need to be cutting these foods out altogether. Here, you can trial over time what works for you. Spreading out lactose-containing foods over the day is also another great strategy. Then there is the use of external lactase enzyme supplements as pills or liquids that pre-digest lactose. And if you're looking for a true alternative to cow's milk, then check out my previous podcast, episode 51, on how the plant-based milks compare. Spoiler alert, unless it's soy milk, then all of the alt milks are pretty poor substitutes from a nutritional standpoint when comparing them to cow's milk. Now, there is also some evidence and plenty of anecdotal reports that people seem to tolerate A2 milk better. A2 refers to the type of beta-casein protein present in milk. A2 is considered the original variant of beta-casein, as the gene encoding A1 is the result of a point mutation in the A2 gene that results in a single amino acid change in the 209 amino acid chain that is casein. Now, unless you buy branded A2 milk, the milk you're drinking will likely contain a mix of A1 and A2 proteins. Rather than being related to lactase activity, it is thought that different casein variants affect gastrointestinal motility differently, and this could explain some of the symptoms from a more sluggish gut. Though here, it isn't technically lactose intolerance it's addressing. I'm asked a lot about A2 milk, and I have no strong scientific views either way on A2 versus A1 milk, as when I look at the research, I do struggle to get excited about the wider narrative of it. If you find you tolerate A2 milk better, then keep drinking it. But if you don't find any difference, then maybe question if the price premium of A2 is worth it. The final treatment option for lactose intolerance is with probiotics, which do, after all, love a meal of lactose. Several studies have been conducted, and in some cases, both a reduction in the amount of exhaled hydrogen and an improvement in symptoms have been seen. But the research here is very mixed, and this was the finding of a 2019 systematic review, which I'll link to in the show notes, which looked at 15 randomized controlled trials and 8 different species of bacteria. Overall, there was a benefit, but it was by no means uniform. Common strains used included Lactobacillus acidophilus, Lactobacillus reuteri, Lactobacillus rhamnosus, Lactobacillus bulgaricus, Bifidobacterium longum, Bifidobacterium bifidum, and Streptococcus thermophilus. as these would be the ones to look out for if you want to do a bit of self-experimentation with probiotics to treat your lactose intolerance. So let's wrap this up. There is no standard treatment for lactose intolerance, and this is a clear example where personalised advice and some degree of self-experimentation is clearly supported. From complete avoidance to determining the type and amount of dairy foods that can be eaten without an issue can all be considered, with further options to look at, including lactose-reduced products or even probiotics. So that's it for today's show. You can find the show notes either in the app you're listening to this podcast on, if it supports it, or else head over to my webpage at thinkingnutrition.com.au and click on the podcast section to find this episode to read the show notes. If you find this podcast of value, then please consider sharing it with your friends and colleagues, or maybe even leave a review. This all helps increase the ranking and reach of the podcast, which means a big win for credible, evidence-based nutrition messages while helping to dilute out the crazy and making the world a slightly less confusing place. I'm Tim Crow, and you've been listening to Thinking Nutrition.